And also, for those of you, if you haven't had a chance to look at my TypeScript GitHub, I made a little repository that I will paste in the chat. You are welcome to clone it down and play around with it. It's basically just a little playground environment that includes testing. So you can write tests in TypeScript as well and run them and just kind of get comfortable with the syntax. So that is there. I'm going to share my screen and we will do the thing. I have a hair in my mouth. Ugh. Well, I guess that's recorded now. Oh well. Okay. Let me open up my playground here. Alrighty. Okay, so today, hopefully, my goal is to kind of introduce generic types as well as some of the little keywords like type of and key of that are kind of useful for obtaining types like in runtime, like again, dynamically, so that you can see all the cool stuff you can do with TypeScript. And then we may get to overloads depending on how far we get. So we'll be able to, we'll go ahead and take a look at some of the functions that that already exist in the playground, and we'll kind of go over how they work, what they're doing, how they utilize generic types. But first, let's introduce them. So a generic type is basically it acts as a variable. So in the sense that it's a stand-in for an actual type. So there's kind of like an extra layer of abstraction here. A type is already a pretty abstract concept, right? A type is sort of representative of a category that particular values can belong to. For example, like the string ABC, of course, is a string type. And a number like 123, of course, is the number type. True and false are instances of the Boolean type. So when we talk about a generic type, what we mean is some sort of stand-in for some arbitrary type. And we can, and TypeScript allows us to be, to enforce how these types are used. So for example, this is really useful for when we don't actually know what type is going to be used in some context. So for example, a function. Let's look at one of the first array methods you learn, of course, is map. So we're going to look at map. Filter is also really cool, which we'll look at that as well. So for example, map. Now the map function is kind of this really, really general purpose function where we take an array of something. We don't know what it contains. The map function itself doesn't really care what the array contains. But all the map does is it takes an array of things and for each element transforms it into a different one based on some rule that you provide to the map function in the form of a callback. And what you get is, of course, a new array. So, of course, one simple example is if you want to perform some mathematical operation on an array of numbers, you can do something like this. 1, 2, 3, and I can say dot map, And I can say, hey, take each number and return x times 2. So that will give us, let's console log that guy. That will give us, let's comment that out. That will give us an array of numbers that have that are the result of that transformation function. So just so we can see it, let's run the playground task. And we should see 246. There it is. Okay, cool. Now, one thing to notice, now I'm using the built-in array function, but notice how I didn't really do anything fancy here as far as TypeScript goes. I didn't define any types. I didn't even define the type of this parameter. This looks like normal JavaScript, and it is. However, if we hover over some of these values, notice how it actually knows that that's a number. Like, even though I'm calling the generic map function on an array, it somehow is able to infer based on this array that this is actually a number. And not only that, but that this function outputs a number. You can see it to the right of that colon right here. It knows that, if we look at this callback function, we know that it's a value, and it's outputting a number. Well, that's kind of amazing that it knows that. The reason why is because TypeScript can infer types based on values. So it can infer that, okay, well, this is an array of numbers, because it has 1, 2, 3. Those are all numbers. So therefore, it's an array of numbers. Okay, cool. So how, though, does it know that? How are we able to tell the map to be, how does TypeScript know how to do that? How can we tell map to behave in this way and be kind of smart about what it takes? This is where generic types are incredibly useful. So let's do some simple examples, then we'll come back to the map. And feel free to stop me with any questions, either in the chat or you can just yell at me, it's fine. All right, so in TypeScript, generic types are conventionally written as a single capital letter. The reason why is to kind of visually separate it from existing defined types. Because, for example, if you have an alias that looks like, here I have some type, and I say that, okay, foo, near a string. Okay, but then I define a generic type as, let's say, type another type. This can be a little confusing because it's kind of hard at a glance without reading, without really looking at that. At a glance, this looks like it's been defined somewhere in a non-generic context. So generally types are defined, or we use single capital letters to define generic types. So that way, when we see something like this, it's very obvious just at a glance. Oh, that's a generic type. So that's just a stand-in for something. Okay, so let's see how this works. We're just going to do a little example. This will be a little arbitrary at first. So the syntax for when you're defining a generic type, and it depends on what you're doing. You can use it in using the type alias. So for example, let's say I have a user. And user is some thing, some object. And we'll call it unique property. Unique or call it unique value. What we can do is we can say, okay, this user, when we define a user type, we invoke it with a generic. So in this case, I'll just do U for unique value, and then I can do this. Okay, so then that means that if I define some user, it has to have a unique value. But notice it's actually yelling at me before I even get to this part. Let's see what it's yelling at me for. User is assigned a value, or sorry, that's not the right one. Generic type user requires one type argument. Okay, so this is a, if you notice, it's kind of like a function. When you don't provide it with enough arguments, your function kind of doesn't work usually. So in this case, we're saying, okay, user, if we're gonna say that user is a type, we have to invoke it with the type that it is expecting. So it's expecting this to be something. Okay, so in this case, we'll make it simple and we'll use a type that we're already familiar with. We'll just say a number. Again, this is very arbitrary, but here we go. So now we'll just say 10, for example. Okay, so now this is okay. I could do another one, so another user, and I could say, okay, you're a string. Now when I do my unique value, if I try to do it with a number again, I'm going to have a problem because now it's saying 10 number is not assignable to type string. It's expecting that this is a string. So now we have no problem. I want to stop there. Does anybody have any questions about that? I hope that makes sense. Cool.
Makes sense.
Beautiful. All right, so excuse me. All right, so now what's cool about these is that we can define our generic types just like a function argument. Like this can be really anything we want. So there's nothing stopping me from saying, okay, special user being either, we can construct all sorts of types and we can inject it into this type, or inject it as a type argument. So just as an example for just how you can use it, I could say you are either a Boolean or you're this interface that has some type. We'll say, I don't know, you're a string. Okay, so what that means is when I define this special user, I'm going to have to say you're either a Boolean, so that'll work. That'll be just fine. I could also do that. That will just be fine. If I try to do like a number though, that's not going to work because 10 is not a Boolean or this random object. So I would have to say, okay, that will work. This won't work though, because foo has to be a number, or sorry, it has to be a string, and we're saying it's a number. So this is really cool. I don't know about you guys, but I think that's pretty cool. Now, I did this with the type alias, but you can also define generic types when you're defining interfaces as well. So I can also do this. I could say interface user, and this will also work. And let's do that so it doesn't break it. Okay, cool. So I can also define generics as part of interfaces. I can also do it as part of classes, just so you know. But the most common is, well, those are probably the most 3 common ways of using generics. Actually, no, there's 4 ways, and I'm going to show you the 4th one in a second. So we can do this with interfaces. We can do this with type aliases. We can do this with classes. So when we're defining a class, let me just do a quick example. So we can do this. This is perfectly fine. Let's just name. So for example, if I have some name, okay, cool, and then I can then say I don't know, some special thing, which is of the T persuasion. We'll say this dot special equals special. And then this is a T. So that is how you do it in a class. Now, a really, really common one, which I have not mentioned yet. It's a little more challenging to wrap your head around, but it's very common. It's probably, honestly, it's probably more common than anything else. And it is the using generic types and functions. So, for example, let's say that I want to arrayify, which just means this will be arbitrary, but let's say this function takes arguments and then is going to output them simply as an array. I don't know why you would do this, but it'll demonstrate the concept. So arrayify is a function which takes arbitrarily many arguments, and it's going to return args. Okay. All right. Now we don't know what this is, but we also don't want. This is what we want to avoid. We want to avoid this idea of using any. In just about every situation, any is a pretty useless type. You might as well not use TypeScript if you're going to be okay with any. Now, I offhand, I can't think of a situation where like it's unavoidable, but you generally want to avoid it as much as possible because it's just too wide open. The whole purpose of TypeScript is to enforce types. So we want to avoid this. So now what we can do, the problem is that I don't know what this is going to be. Like, is this an array of Booleans? I don't know. Is this an array of animals? Is this an array of users with the number special type thing? I don't know. There's no way to know. So what we want to do is put in a stand-in. So again, we'll use generic types for this. So we're going to say that you are an array of something. And that something we're going to define as V. So this is, I know it looks a little weird, but this is how you define a generic type on a function. So V will be our stand-in. So now what we can do is we can say, okay, my arguments are going to be an array of whatever V happens to be. And we won't know that until we actually invoke the function call. Okay, and then the return value, we're still, notice how TypeScript's still yelling at us. Oh, that's a linting error. But there we go. So we know that this function returns an array of V, and we could also be a little more explicit here. We could do that, for example. So when we call this function arrayify, now we're going to have to tell it what types to expect. Now, if I just start putting in numbers, check it out. Now it knows. One thing I want to point out is look how when I do this with empty, with nothing in it, it infers that it is unknown. That's pretty cool. So at this point, it doesn't know. It doesn't know what you want. You're passing nothing in. So how is it supposed to know what that array is going to contain? But what's cool is the moment I start putting values in here, TypeScript can then infer. But it can also start doing some very interesting things. Like if let's say this is not only numbers, but also Booleans. So now we have a problem because we are not, while TypeScript can infer to some degree, it's perfectly fine if you stick with one type, but the moment you stray, now it's starting to get like, oh, what do you want? What do you want from me? You said that it was going to be an array of numbers, but now all of a sudden, now you're changing your mind. So whatever that first argument is, it'll be okay with that as long as you keep following the pattern. But if we want to change things up, such as this, for example, then we've got to be a little bit more particular. So this is where functions are a little bit more interesting than interfaces and types and classes, because when you invoke a function, this is where you can be really particular about what types you want it to use. So again, we're going to use this weird double or bracket syntax, and now we're simply going to define what the types are that these values can be, which of course in this case is string or number or Boolean. And now there's no problem. Our compiler is perfectly happy with that. And we could also do this. We could also do this. It would be a little redundant if we knew ahead of time that this is always going to be, if these were all going to be strings, but this can actually be, this can be helpful as well. So, and the syntax is pretty much identical with normal functions. So, or I should say, the function declaration syntax. So like if I wrote this the same way, it would be pretty much the same, like this. So just so you know, same thing. All right, anybody have any questions? Is this all making sense? Cool. All right, so let's take a sec and let's look at the map function. I'm gonna kind of get rid of some of these guys, clean it up a little bit. All right, let's look at the map function. So I've written my own implementation of map, which is pretty close to the JavaScript implementation. I'm missing a few things, such as the ability to have a reference to the array inside of the callback, as well as changing the this context. But this is pretty much, other than that, it's virtually the same idea. You take an array of things, you loop through it and return in a new array with things that have been put through some sort of transformation function, which is in this case the callback. So let's look at this. So map, it's a function. Obviously, there's my arrow. So let's look at the argument. So we'll come back to this in a second. I know that looks a little weird. Array, we're saying, okay, you're an array of something, some generic type V. Okay. Callback is a function. So notice this is just another, I've simply put the function in as a, how do I put it? I've just defined the callback type, right in line with the map. I could just as easily define a callback type up here. Do something like this, where we have our value and our stuff, but I'll hold off on that for right now. We'll get back to that. I don't want to overcomplicate things. So our callback function is just, we're defining a type for it. So our callback is just a function that takes v as an argument. So for those of you who have used map and filter and all that, which I assume you have, that just represents a placeholder for each individual item in the array. And we're saying, hey, you are of the type v, which is again arbitrarily decided here. So we won't know what that is until we actually invoke the function. That's the whole purpose of a generic value, is to not enforce the type until it has been until it's time to use it. So, and then of course the second argument is just the index, which is just helpful for callbacks. It's just helpful to know what iteration you're on. Okay, and then our callback, notice it returns n. Okay, well, n in this case is simply another generic type. Now, this is not entirely necessary. I could have just as well written that. All this means is that if one is not provided, to simply default to the same type as v. So that simply just means that if you're not fundamentally changing the type that your callback transforms your original values to, then this just says, hey, just default to the same type. So for example, if we go into the test where I run this a few times. So for example, here's a case where if I'm just doubling numbers, if you look at this callback, notice I'm just multiplying each item by 2, I'm going to get the same type back. So there's no, it'll just know, notice how when I hover over it, it knows that, hey, your second argument's a number. It's just defaulting to number because that's what this array contains. Now, if we look at the second one, that's a string, and that's because a callback here, we've told it to return a string. So in this case, all it's doing is stringifying the number. It's just saying, take a 1, turn it into a string. And so we get that. So that's simply what that means. We're just saying default to the same type as what the original array is, unless otherwise specified. It's kind of like it behaves very, very similar to default values or default arguments in functions. So it's an ES6 functionality or feature, I guess. Okay, cool. So then, okay, so that's our callback. So pass in an array, pass in a callback, and what we're going to get back from the map function is, of course, an array of whatever values n is. So that's kind of, we've kind of come full circle. Start with an array of v, default our outputs to v if we don't specify one, and return an array of values that match type n, whether that is v or something else that is determined. So now this function has no idea what n is. It really doesn't. All it knows is it could be n and it could be v, whatever those are. It doesn't know, it doesn't care, and it doesn't need to care. All it needs to care about is that as we're trucking it through this function, that the values that we're putting into this array, we just care that it matches up. So let's look at how this works. So the logic, of course, of a map is to simply start with an array, an empty array, loop through the original array that has been given, snag that element at that location in the index of the original array, snap that thing, whatever it may be, and transform it via the callback, and whatever the output of that callback is, to just push it into the new array. And we just do that for each element. So at the end of the day, we get an array of, or we get a new array that has the same number of things as the original one did, just with values that have been put through this function. So in TypeScript, what we're saying is, hey, output, you are going to be the array that we return from this function. And so for that to work, which we are here saying, hey, map, you need to return an array of this, whatever that is, the whatever type corresponds to the transformed value. That's the job of the map function. You need to return an array of values that match that type. So we're going to define this empty array as an array containing n, so that at the end of our loop, we can simply output that array. If I try to take this away, we would have, well, we won't really have that big of a problem because it's able to infer it. So that was actually redundant. So I didn't actually need to put that there, but I think it's helpful anyways. It's never a bad idea to be overly careful, I suppose. Anywho, so this output is an array containing our transformed values represented by n. We loop through the item. We take the current item that we're on, and notice how it knows, if I hover over this element, notice how it knows that that's a v. That's because if I'm extracting an item out of an array, which I've already defined above, which is an array of v, then it knows the element must be a v. It's, again, TypeScript is very good at inferring values, or inferring types from previous values. So our element is a v. Now, when we do our callback function, notice it's expecting a v right here. So it's expecting a v, and it's expecting another argument, I, which is a number. So we know that I is a number because, well, it's defined here. Now, if I were to sabotage this and put, like, I don't know, 10, well, now I have a problem, because argument of type number is not assignable to parameter of type v. This is an error that you'll see all the time. It drove me crazy when I was first learning TypeScript because I did not understand generics for a long time. It's saying argument of type number is not assignable to parameter of type v. V could be instantiated with an arbitrary type, which could be unrelated to number. So let's break that error down. Understanding this error is pretty much paramount to understanding generics. What this is saying is that this v value is way, way, way less specific than this type. This is a number, 100% a number. V, it could be anything. It really could. And if this callback is expecting v, well, number is way too specific, so that doesn't match. Now, it could be a number. There's nothing that prevents v from being a number, but the problem is that this is not necessarily of the type v, which is why we get that error. It's like, it's saying, look, you're telling me that this is supposed to be a v, but number and v are not necessarily the same thing. So that's why you got to be careful. So once I put an element in there, though, which, since this has already been defined as an array containing types v, well, now there's no problem, because whatever that is, and it may be a number, right? It could very well be a number. But regardless of what it actually is, it's now getting the right, or it's at least receiving what it is expecting. It's expecting a v type. Beautiful, no problems. We can simply carry on with our lives. So that's what's going on in this map function. Any questions?
No.
Cool. That's either a good sign or a bad sign.
Okay, Ben, I do have one question, but
Wait,
I'm afraid it's a stupid question, but I'm just going to ask it.
do it.
So you're using I in your for loop, but
Uh-huh.
I is also a type. That I find that confusing. In the
Oh,
call.
wait. Sorry, say that again.
Oh yeah, sorry. So in your callback where you've typed
Uh-huh.
the two inputs, you have I as the type, or as the argument of I is the type number, but then you're also using I in your for loop, and I'm just confused by.
Oh, I see. Yeah, so this is actually a case of I should probably just do that. That still works because since this is a type and not a value, you're not going to have any like weird scoping issues or anything because like they are like completely different
Okay, yeah, that helps
things.
me understand better.
Yeah, I'm
My
glad you
brain
pointed
wanted
that
to
out.
completely understand that the I down here in the function body is not related to that
Yes,
argument.
yes, that is a really good point. Yeah, I'm glad you pointed that out. So that was not a stupid question at all.
When
That was very astute. That was an astute observation, which is the exact opposite of a stupid question. So good job.
thanks for clearing that up.
Yeah. So for everyone else, I just like I could call that anything I want. Like this could be elephant. It doesn't matter what that is. Calling an index, of course, makes sense because that's what it's representing, right? But this callback here. So one of the things that really confused me when I was learning TypeScript is function types. Like this looks like a actual function, but it's not. It's a function type. It's a type that is defining the shape of a function. Okay. So the first tip or the first way you kind of know is this isn't a real value, right? Like n hasn't been defined as a variable. It's been defined as a generic type, right? It's a type variable. I mean, I don't like to use the word variable when I'm talking about generic types because that makes it even more confusing than it already is. So n is a generic type, which just means that it's a category. So a value could be a member of that category, right? But when you look at this and you see that this function, this I quote function, you see it outputting a type, that should immediately tell you, oh wait, this is a function type, not a function value. And that is a very important distinction. So this actually brings me to kind of what I was going to do earlier, but I stopped myself because I wanted to finish the rest of this. But let's look at, so this, I want this to become very clear about what's happening here. So map is a function which takes two arguments, an array and a callback. Okay, so when you're defining a function type, you have to define what the types are of its arguments. Okay, so this one is, I think, intuitive to follow. The first argument is simply an array. Okay, the second argument is a callback function. Okay, well, it's a function. So that means that if we're going to define the shape, so again, to go back to the fact that we're trying to define the types that this map function takes as arguments, we now have to define the type that this argument is. Well, it's a function, so we have to define it as a type. So what we're going to do is we're going to extract this from its context. We're going to basically put it in its own type, so you can see how this is actually a type, not a real function. So let's do map callback. Okay, we're going to define this as its own kind of type. So, all right, so we know that it's a function that does something. Okay, cool. Now this function takes some value as an argument, and it takes an index as a number, and it returns something. So we kind of have to know what this something is. Now, here's the problem. This was really the bottleneck that I hit when I was learning TypeScript. Like this right here was trying to figure out what the hell to do here. Because it seems like I have two options. It seems like, okay, well, if we're going to be using generic types, then don't I simply just do V and then N and then say that this is V and that this is N? Like, okay, syntax works out. Okay, great. And let's do this thing. So we'll take this out, and now we're going to replace this with our map callback. Okay, so this seems to work. However, notice how here everything seems to be fine. But when we go up here, we now have a problem. When we look at our map, we're getting some weird stuff now. Let's look at this. Let's look at this area. So this callback is what's causing the problems. Okay, so this callback function is saying, okay, so again, we've already defined it, right? We're saying, hey, map callback, you take V, whatever that may be, as an argument, and output N, whatever that may be. And if we look at the way that we're invoking this function, like we're passing this function into the argument, okay, cool. There's our array of numbers. Okay, great, no problem. The problem, though, however, is the way that this callback is being defined. The error says the left-hand side of an arithmetic operation must be of type any number, big int, or an enum type. Okay, fine. And then if we look at this, type number is not assignable to type n. There's that error again. We're saying this callback function is saying that like we as humans look at this and we're like, well, this is obviously a number. But remember, to TypeScript, all we did was say that this is a placeholder. This is a V. So multiplying V, whatever that may be, times 2, well, what if that's an array? When you multiply an array by 2, that's a nonsensical operation. Like that doesn't really, that isn't really a thing. I mean, it is, it'll give you not a number, but that's not very helpful. What if that's an object? What if that's a string? Like that's where TypeScript is looking at this being like, this doesn't seem right to me. You're saying that V is to be multiplied by 2, but V, you're telling me that V is some weird ethereal type. You don't, like, how am I supposed to know that V times 2 is actually a meaningful operation? So we have this problem. Type number is not assignable to type n. N could be instantiated with an arbitrary type, which could be unrelated to number. All that means is that this value that we've outputted from this function is too specific for n. Because again, n could be anything. So, all right, well, let's see what happens if we let's see what happens if we try to fix it. So, okay, let's go in here and maybe we can do something like this, maybe? Like, can we say number and number? Wah, wah. Nope, now we're getting into TypeScript hell. And this is where I spent a lot of time. So this doesn't work. It's not gonna, this isn't gonna work. Because first of all, this is this is an actual function. We're not defining a function type. This is a real function. So this isn't going to work. That syntax doesn't work. This only works for types. This syntax only works when you're defining types. I cannot tell you how long I spent in TypeScript hell with this very problem. So, okay, so let's look at another option. Well, okay, I guess we could go over here and say, okay, well, the problem is clearly this. because nowhere is v or n actually defined. So, okay, well, let's maybe try this. Like, okay, we'll say your v and your n. Okay. Okay, cool. So now we're being a little bit more specific. We're saying, hey, callback, you are those values. You are v and you are n, which we're getting from the actual map. We're getting this from the actual context. Okay, cool. Well, unfortunately, it's not good enough. It's not good enough for this. Well, let's try this. Let's do maybe number and number. Still not good enough. TypeScript still cannot quite wrap its head around what n is. Now, there's a few cheater things we can do, I think. We can use the TypeScript syntax such as, or we can use the TypeScript keyword as, which might help. Oh, that's not gonna work. Let's do this. And then maybe this, maybe. Now we're getting into weird stuff. This just isn't gonna work. This is another error that I spent a long time in TypeScript hell trying to understand. Conversion of type V to type number may be a mistake because neither type sufficiently overlaps with the other. The problem here is that, again, TypeScript is having a hard time understanding what this V type is. And even if we try to override it and say, hey, no, you are a number. And then we're trying to say, hey, this value right here, you are n. Sorry, number. It just, the bottleneck again is this value right here. It's trying to understand what V is, and then it's also trying to understand what the return value of this callback is. So let's try a few other things. Okay, so let's put this back to how it was. Yeah. No, there we go. Okay. Yeah, okay, cool. Okay, so let's try a few other things. We'll go back to our map function. And okay, so the problem, this is where I realized that this right here, when you're defining generic types in a function, these are only relevant to when you're actually invoking the function. And if you look at the way that we use the map function, when we invoke this callback right here, we are actually, there's nowhere that we don't have a chance to define the types that go into this function, because we never actually call this. The map function does. It's like a black box. This function is being used under the hood. So it's buried in here somewhere. So when we're using it in the real world, map is living in this, library essentially, and it's invoking the callback. So we don't have control over how it's being invoked. Only the map does. So we have to respect that. So we're going to get rid of this. And what we're going to do is we're going to use generics in the way that it's supposed to in this context. So while yes, these are generics, they're only useful for when we actually are calling or invoking that function. So we don't know what this is. The only time to use this is when we don't know what those values are until we run it or until we invoke it. So now sometimes we actually do know what they're going to be ahead of time when we actually define the type. So that is, I think, the subtle distinction that's really important to remember, is that there's actually two potential times when you can know the types that a function can have. we can know the parameters, we can know the types of the parameters at runtime when we invoke the function, and we also may know it earlier. This is a case where we're actually going to know what values these are prior to invoking the function. It's going to be here. We know, because v and n have been defined here, we know that this actually is going to be related to v and n. So we're going to use this guy. Now, instead of putting this here, we're going to put it here. And all our troubles seem to be resolved. It is now able to properly deduce that that is a number based on the array of numbers here. And it's also able to know that, hey, that's a number. And in fact, if I tried to do something like this, we're not going to have a problem, because it's going to say, hey, man, this is supposed to be a number. You just turned into a string. So that right there, what I just showed you, is the most complicated part of TypeScript that I have personally struggled with. So I'm super glad that you guys had someone to tell you about it, because I didn't. I don't know if I did a good job explaining it though. So it is very complicated, and there's a lot of moving parts. So if you're confused or have questions, that is totally fine. So I'm happy to try to clarify anything that I can.
I guess I'll be a little honest and say it's a bit over my head. I'm kind of just trying to start with the basics.
That's all right. That's totally fine. To try to boil it down is when generic types and functions, while they're probably the most powerful aspect of TypeScript, in my opinion, definitely the most useful. I'm sure people would disagree, but I think it's tremendously useful, generic types. But I think the key here, to try to simplify it as much as I can, is to be just very aware of when you know what a type is going to be in a given situation. So in the case of a map, we're able to know that the type signature for the callback is determined when we invoke the map function. Therefore, we can define that signature prior to it being called. We can define the signature of the callback prior to it being called. When I say signature, I mean the type that we assign it. So we're able to say, hey, map callback, you are a callback function, or you're a function that takes v as an argument, which is of the type v, which is arbitrary, an index, which is a number, and you return some other value n. And so that's it. That's what that callback is. So that means that when this callback is invoked later on, it is guaranteed that this guy is going to output n, because that's what we told it it does. And it takes v as an argument, or it takes an argument which is of the type v, because it's been defined in its signature there, and that's what we're putting in there, as well as the index right there. So knowing when a type signature can be defined is, I think, the holy grail, or the real crux of TypeScript. Once you can master that, I think everything else falls into place. And for me, it took me several months for things to really fall into place in my head. And hopefully this will get you guys there faster than it took me. So those are that's kind of the core of generic types. There's a couple other things I want to mention, but I also want to leave things open to questions as much as possible. So if you guys have questions, let me know. Otherwise, I'll go into the next thing.
I guess my question is maybe a bit more practical.
Yeah.
Trying to through like a very simple coding challenge we got today using readline sync and
Okay.
sort of doing it in TypeScript, but I don't want to kind of maybe hog the whole.
What's the problem? What's the question?
Basically create a dictionary. So readline sync where you ask a question, say, what word do you want to store? What's the definition? And then be able to either store the word or look up the word or, quit more or less.
Oh, okay. Okay.
So I've written that kind of here, but yeah, kind of just curious on the sort of conversion to TypeScript, sort of with adding, like you have there, like where do you put string? How do you add it in front of a function? Again, a bit more on the basics here, so I don't want to necessarily take
how
everybody
about
else's interest.
If no one else has any questions, I'd love to go into that. And if they do, I'd be happy to go into it after that. Because the only reason I say that is because I'm going to set that up in a slightly different package because readline sync is it's kind of weird. I've never done it.
I think, and I've got it running here in your playground.
Oh, you installed readline sync in it?
Yeah, and I think I just had to import it instead of require it.
Right.
So I could share my screen and you could try to walk me through it, or again, pretty open.
Yeah, let's do that.
All right, I think you just have to enable it there.
Oh, yep. There you go.
Okay, so I just whipped this up.
Cool.
And again, the goal of like thinking simple in order to sort of start to understand these things. So feedback welcome on the overall structure in general. But we have a dictionary, which is an object. We import readline sync, basically run sort of a run function. Or we use a Boolean for this kind of run function. And while that's true, we basically run through this loop here until we set it to false when we quit.
Okay, cool.
And so like kind of getting there a little bit, right? So we run the dictionary and we have sort of these three different options we want to choose from. And then our action is basically the result of those three options, which is a number. So 0, 1, 2, 3.
Okay.
And so this, I guess, would be a function, right? So would I put something after this, like, here, or does it go in between?
So it knows, it's able to infer. So if you hover over key and select, it'll tell you like that it already knows that it's taking an array of strings.
And that's because you set it.
Yeah, and in fact, TypeScript is even smart enough to deduce that is an array of strings without even setting it. That's what's
Okay.
nice about literal values. So like even line 14, you don't, it's actually a little redundant to do string array. So there's nothing you need to worry about as far as so line 14 and 15, it's the key and select method. It already knows what it's expecting. So there's nothing fancy you need to do there. And in fact, because the return value of key and select, its signature says that it's outputting a number, even action doesn't have to be defined as a number. Because it's already inferred by the fact that the signature of key and select, that the return signature is a number. So action can't be anything other than a number.
And so where does you see that sort of signature concept?
So it's at the very end. Yeah. See where it says colon number?
I see. So that's
Yeah,
kind of
so that's the return
way
signature.
that's the way types sort of sees it returning, or what types
Right.
understands it to
Everything in
return.
red. Yeah. So everything in red there is those are the arguments. And anything in yellow is a type. So basically it's saying items, it takes key and select takes an argument items, which is an array of strings. Query is an optional property, which is anything. I'm surprised it doesn't say string. And then options is an array, or sorry, is it's either undefined or it is a set of read line sync dot basic options. So,
Okay.
and again, that's defined in the actual library itself. And then the output. So at the end of that, there's no more parameters left to list. So the colon is the syntax for return value. So we're saying
Got it.
this key and select, its return signature is a number.
Cool. Okay.
So therefore, action, because you're storing that output value as or you're storing that output value in a variable called action, because that signature is a number, then action is a number. So you don't need that.
Really don't need that. Okay.
Exactly. Cool.
Cool. And so now we've basically defined our types. And that, this is an array of strings. This is
that's also redundant because store, lookup, and quit are all strings, and TypeScript is smart enough to deduce that those are strings because they're literal values. Yeah.
And I guess that's why it wasn't really yelling at me when I was just basically writing basic JavaScript here.
Exactly. Yeah. So like
super upset.
One of the things that's funny about TypeScript is that you start learning when you don't have to actually write types. But the key here, though, is your problem is happening on line 24. That's
right.
That's where things get very interesting.
And so because it kind of knows, it knows that this is going to be a number, so I don't need to do anything here.
Right.
It knows that this will be a string.
Yep.
Thing with this, and now we have kind of this idea of like storing that information in our object, or our dictionary object. So this, I haven't really set anything up here. Like you wouldn't need to. There isn't an object type, is there? Or would we use an interface, or am I getting ahead of myself?
So this is so that's a good question. So there is a type for object, but it's so abstract that it is almost useless, because pretty much everything in JavaScript is an object. For the most part. So that's why interfaces are a lot more useful. You can also there's some built-in types for defining objects as well. So the first thing to do is let's look at what that error says on line 24. If you hover over it, what does it tell you?
Element implicitly has an any type because expression of type string can't be used to index type empty object.
Yeah. Okay. So let's unpack that. So that means, what we're trying to do is we're trying to ask the dictionary a question, right? We're saying, hey, dictionary, do you have this property or not?
Right.
And the way that you ask an object whether you have a property or not is to use the bracket notation and ask, are you undefined or not? Well, in order to even be able to access a property of an object, that property name has to actually be something that the object is indexable by. So objects are indexable by strings, by numbers, and by symbols, but we don't need to worry about symbols right now. Let's just first worry about numbers and strings. So when something is indexable, that just simply means that you can use a string or a number to access the location of something on an object. That's all that indexable means.
Right.
So the problem here is that you're using this variable which is called word, right?
Mm-hmm.
And
It doesn't know what
and it's
that
not,
is.
yeah, we can't index type empty object. That's basically what it's saying. So
And so
what we
this is
need
where
to
we need an interface, I would
we need a
guess.
better way of defining what dictionary is. Saying that it's an
Yeah.
empty object is not very helpful. So what we should do is on line 4, let's define dictionary as a more specific type. And there's actually a built-in type that's going to be useful here. So we don't actually need to define our own type. So after dictionary, let's just use the colon syntax, and we'll use the built-in type called record.
So
And record, yep. And then record takes 2 type arguments. So we're going to put two of the angle brackets there. Yep. So the first argument is going to be what is it indexable by? So in this case, it's going to be a string. This is just a dictionary, so string is totally fine. And then the second argument is just string again.
yeah.
And they're separated by commas, just like a normal function. You don't need to. It's not 2 sets of anchor tags. No, sorry, that you had it right first. Take out that comma, yeah, and then it instead of there's only 1 set of brackets.
1 set of brackets.
Yeah, you have 2 sets, yeah, and then put a comma. There you go.
Okay.
There you go. Cool.
So
Okay.
record takes 2 basically 2 strings, the key and the value.
Yeah. So what
the index is the string. What it's going to search by is a
Yes.
string, and then
Yes.
what it returns or the result of that search is a string.
It would be more accurate to say that the dictionary is of a type record invoked with the type arguments of string as its first argument, which is what it's indexable by, and second, what the corresponding value is at that index. So we're simply defining what the property types are and what the value types are. So they don't, in this case, it's just a coincidence that they're both strings. The second argument could literally be anything.
Right.
That's why records are really useful, because you could have, it could be an extraordinarily complicated type, right? We could have a record that has string properties, but then arrays of objects with nested properties and stuff like that as your second or as your value. In this case,
So that's where you could have like an array of
right. That could
strings
be anything.
Whatever.
Yeah.
Yep. Okay.
Yep. Exactly.
But this is sort of what the property it's going to sort of index or match on or something like that.
Yep. So that we're using string because we know that there's just going to be words.
Cool. Now we don't get an error.
And now the error is gone because it knows that dictionary is indexable by strings, and because word is just a string, it's perfectly acceptable. There is a couple problems with your logic though. On line 20, your dictionary, you're overriding the whole thing.
Yeah, I just saw that myself.
Yeah, so you'll just want to use the triple or the triple dot spread operator to. Well, there's a couple ways you could do it. You could either just say dictionary bracket word equals definition. That would probably be the simplest.
Okay.
Yeah, and then you're not
Equals.
duplicating the. Yeah, there you go. Use equal instead of colon. That's when I was learning TypeScript, I started doing that all the time. Cool. So now we're saying, hey, dictionary word is equal to that thing. Cool.
Right. Cool. All right. Sweet. Well, that.
And then, however, you have a problem because so that's the linter is
Oh,
just
so
saying, hey,
yeah.
why are you using let?
Const,
Like there's no reason
right,
to use yeah, there you go.
Yeah, it caught me a few times already on that, which is actually a really handy
Oh, so handy.
tip where you're like, oh, thanks, I'll get better at not doing let all the time.
Right. Yeah. So now does this work now? Is it
I can try to run it here.
will it run?
Store. Oh, I think I had this wrong. Should be 0 and this should be
Then you'll have your
get out of this. See. Oh, I don't have my else yet. Sorry. So we gotta. How do I break out of this in TypeScript? I guess.
Same. There's nothing different.
Control.
Oh,
C.
you're in the sorry, you're gonna have to hit the trash can because you're in the middle of a
Okay.
there you go.
So we have to add our.
Yeah. So
else
first of all, when
here.
when this code's running, you're not running TypeScript. You're running JavaScript. So
Right. It's just.
by the time it's runtime, it's no longer TypeScript because
So yeah,
TypeScript is not a runtime language.
basically just want to do.
Yes. You could also just break. You could just like run a break. You don't really need the run dictionary value technically.
And so the semicolons in the linter, like a prettier or something like that, could sort of help clean up some of that automatically on save.
Yeah, you just have to go into your VS Code settings.
Okay. Let's see here. So.
And there's also a hotkey if you do. Are you on a Mac?
Yep.
I believe it is Shift Alt F.
For format on save.
It will well, it'll just format. It's not a save. It just formats automatically.
Shift Alt F.
I think it might be something else. I don't actually remember. I have on Windows.
Oh,
so.
yeah, Shift Alt F.
Yeah, Shift Alt F. Yeah, that's right. Okay, so
I think that's where
it won't. Yeah, it doesn't respect your linter. You'll have to go into your VS Code settings to mess around with that. There it is. Or did that work?
There you go. Yeah.
Cool.
So pretty straightforward. Cool. Yeah. Thank you. I just thought that would help me sort of understand a little better.
Yeah.
At least to get a look my feet wet here.
Yeah, and like this is an example of how TypeScript actually doesn't always make your code 10 times longer.
Right.
Just a few well-placed types can actually, can be pretty helpful.
Cool. Well, yeah, thanks for entertaining me there.
Yeah, no problem. Does anybody else have any questions or things they are working on or need some help at? Cool. Well, there's actually one cool thing I wanted to just, I know there's only a few minutes left, but I do want to show something that's kind of cool. That's important regarding generic types. So, so like I was talking about earlier, one of the hardest parts about So one of the kind of trickiest parts of the TypeScript is, especially with generics, is kind of knowing when to define your type. Like, as we saw with the map, it was kind of tricky as far as, oh, where's the map? Here it is. So like in this example, we defined our type using generics, but we did it here instead of before the parentheses. And that's because when we use doing it with the parentheses, that's saying that, hey, we're expecting those types to be defined when we invoke the function, and that's the only time. Whereas if we define generics in our type definition, that means that we have to define the types at the moment that we are invoking the type. So there's two very subtle cases, there's two subtle differences there. Now, sometimes you actually want to glean the type at runtime, and that can be kind of, or I guess I shouldn't say at runtime, but sometimes you want to extract the type from a value, and you may not know what that value is until, or you may not know what that value is. So you may want to extract it. And you also may want to be a little bit more particular about what these generics can be. So for example, let's say that I want to grab the ID from a property. Okay, so like I have a database full of things, and for whatever reason, I have this function called extract ID. Okay, and it's a function that takes some record or document, depending on what type of database you're using. I'm used to using MongoDB, so I'm gonna call it doc, because that's what we representing document, which is what we use to refer to individual items in a Mongo collection. So okay, so what we'll do is we'll say, okay, doc, I just want your ID property. Okay, so now the thing is that while this function, we do expect this to be a property with a dot underscore ID property, just like in Mongo how they define IDs this way. But the problem is that I don't really know or care what collection that comes from. Like this could be literally anything. It's going to have tons of other properties. We just simply care that it has that property. So we now have a kind of a problem, because I don't really have a way of knowing at the time that this is I don't know what document this is. I can at least be assured in knowing that it has an ID property, or at least I want to be able to assume that. I want to be able to assume that doc is an object that has an underscore ID property. But the problem is that I can't just simply say, hey, you are a thing with an ID property, which is a string in Mongo. But then it's just like, okay, but you also have other things. So we have this problem where it's like, okay, how do I define this type? So we have a conundrum. I want to be able to enforce that this thing has an ID property so that I can properly access it. But I also need it to be general enough that it can accommodate any type of document coming from any type of Mongo collection. So I need some like middle ground here. I need it to be specific enough for this particular use case, but general enough that that it's still useful. And generic types, again, come to the rescue. So what we'll do here is we'll say, okay, all right, doc, you are a D. Okay, well now we have that problem where it's like, okay, well, how do I know that ID exists on type D, right? Like TypeScript is looking at this being like, who are you to tell me that this arbitrary D thing has an ID property? And we can be like, all right, well, listen, you are not just some arbitrary type D, or at least you're not that arbitrary. You're just arbitrary enough. And we use this keyword called extends. And what this will do is this allows us to enforce kind of the minimum requirements that this type should have. So what we'll do is we'll say, for example, I'll create a type called doc. Okay, now in Mongoose, they provide this automatically. You have a document, or you have a document type, but just for example purposes, we'll say that doc is a thing that has an ID property that's a string. Okay, cool. So now I can say, hey, this document is generic in the sense that we don't know what it is until we invoke this function, but it's also has to at least pass this basic test that, hey, you have to at least have this ID property. Like, I don't care what you are, but you've got to at least have that, right? It's kind of like, I don't know, getting on an airplane. You got to prove that you have an ID. They don't care. Well, usually they don't care where you're coming from. You know, now that there's COVID and stuff, they do all sorts of extra things. But anyways, you know, in a purely free world, we'd all be able to go anywhere without anyone judging us. And, you know, all we have to do is provide an ID. So in this case, we're just saying, hey, you have to be an object that has an ID property. And other than that, I don't care what you are. So when we use this function, I can only use it on things that have an ID property. So for example, if I do this, that's not going to work. It's going to tell me that argument of type object with a name property is not assignable to parameter of type doc. Object literal may only specify known properties, and name does not exist on type doc. Okay, so notice obviously doc does not have a name property. So we have to make sure that it does. So let's do this. And we'll just give it some arbitrary thing. And look at that. Now it works perfectly fine. And I can add as many properties as I want. And it won't matter. But the moment I take this property out, it yells at me. So this is a really, really, really useful way of enforcing types that need to be just vague enough, but just specific enough to do what you want. And now this is this type. I could define that in an interface just as well. I could just say, okay, let's make a user type. I could do an interface or a doc, but I'll do a type user, for example. And user is going to be a thing with name property and an age property, which is a number. Okay, but I'm also going to say, hey, user, you're also, and there's that union operator, you are also a doc, meaning you are now a user doc. Now, I didn't have to do that. I just decided to do that. Anyways, now what we're saying is user doc is a object that has a name and an age, and then whatever properties doc has. So now this will pass our extract ID test as well. So if I were to say const user equals, and then let's just take this guy, for example. You happen to be a user doc. There we go. So now the moment I remove this ID, Now my user is going to break. It's going to say, hey, look, man, you need an ID. And I'll be like, oh, yeah, sorry, my bad. And then there you are. And now the user is now it matches the signature that the user doc type is requiring. And therefore our extract ID is also accepting that signature. So that's just kind of a cool little thing you can do. I think that's a lot of information for one day. So I hope you guys' brains are full now.
Very full.
We will, but next week my goal is to do a little bit of stuff in React. So you can kind of see how things work in React. It's really not any different than it is here, but it'll be cool to see it in like an actual like framework.
So does like a component have a type?
Yep.
Yeah.
Cool. Yep. Any value in JavaScript either explicitly or implicitly has a type. And so in React, it's just a matter of attributing the proper types or I should say, attributing the proper values to the proper types.
Cool.
And it lets you organize your code in a much better ways, I think. Like it kind of forces you to.
Yeah.
So,
well, thanks, Ben.
Yeah. So yeah, unless you guys have some more questions, that's all I got for today.
Nope, got to keep writing it because that's how you learn.
Yep.
Can't just watch.
Nope, can't just watch.
Well, thanks again. Yeah, Happy New Year, I guess.
Yeah, you too, man.
See you next year.
All righty. Yeah, next year. We'll see you guys.
All right. Thanks.
Cool. All right. Have a good day, everybody.
Bye.
See you later.